Hello class, welcome to STAT 1200. I am your instructor William Buellman, and today we are covering section 5.1, Random Variables. The objectives for this section are to be able to distinguish between discrete and continuous random variables, determine a probability distribution for a discrete random variable, describe the connection between probability distributions and populations, construct a probability histogram for a discrete random variable, compute the mean of a discrete random variable, and compute the variance and standard deviation of a discrete random variable. If we roll a fair dice, the possible outcomes are the numbers 1, 2, 3, 4, 5, and 6, and each of these numbers has a probability of 1/6. Rolling a die is a probability experiment whose outcomes are numbers. The outcomes of such an experiment is called a random variable. Note, a random variable is a numerical outcome of a probability experiment. Discrete random variables are random variables whose possible values can be listed. Examples include the number that comes up on the roll of a die, the number of absences a randomly chosen student has. Also, we have continuous random variables. And continuous random variables are random variables that can take on any value in an interval. Examples include the height of a randomly chosen college student. Another example is the amount of time it took a randomly chosen student to get to school. A probability distribution for a discrete random variable specifies the probability for each possible value of the random variable. The properties of this include 0 is less than or equal to the probability of x, which is less than or equal to 1 for every possible x. Also, the summation of the probabilities of x have to equal 1. So what this is saying is for each probability in the distribution, it has to be between 0 and 1. It could include those values. And when we sum up all those probabilities together, they need to equal 1. Example 1. Decide if the following represents a probability distribution. This is not a probability distribution. Note that P of 3 is equal to negative 0.10, which is not between 0 and 1, thus this cannot be a probability distribution. Example 2. Decide if the following represents a probability distribution. This is also not a probability distribution. All of the probabilities are between 0 and 1 for each x, but if we sum the probabilities together, we see that it is equal to 0.90, which does not equal 1, thus not a probability distribution. Example 3. Decide if the following represents a probability distribution. This is a probability distribution. All of the probabilities are between 0 and 1 for each of the x's, and when you sum them together, we get 1, so thus it is a probability distribution. Example 4. 4 patients have made appointments to have their blood pressure checked at a clinic. Let x be the number of them that missed their appointment. The probability distribution of x is as follows. So the probability that 0 will miss their appointment is 0.27. The probability that 3 will miss their appointment is 0.02. We're going to find the probability that 2 or 3 miss their appointment, more than 1 misses their appointment, and at least 1 misses their appointment. For 2 or 3 miss their appointment, the events 2 and 3 are mutually exclusive since they cannot both happen. we use the addition rule for mutually exclusive events. The probability of 2 or 3 is equal to the probability of 2 plus the probability of 3, which is equal to 0.31 plus 0.02, which is equal to 0.33. So the probability that 2 or 3 miss their appointment is 0.33. What about for the probability that more than 1 misses their appointment? Well, more than 1 means that we have 2, 3, or 4 that miss their appointment. We can again use the addition rule for mutually exclusive events. So the probability of more than 1 is the probability of 2 or 3 or 4, which equals 0.31 plus 0.02 plus 0.25, which is equal to 0.58. And finally, at least 1. So here we're going to use the rule of complements. The complement of at least 1 is that 0 missed their appointment. So remember, the rule of complements says it's 1 minus the complement, which is the probability that 0 missed their appointment, which is equal to 1 minus 0.27, which gives us 0.73. So the probability that at least one person misses their appointment is 0.73. Statisticians are interested in studying samples drawn from population. Random variables are important because when an item is drawn from a random population, the value observed is the value of a random variable. The probability distribution of a random variable tells how frequently we can expect each of the possible values of the random variable to turn up in the sample. Example 5. A theme park parking facility contains 1,000 parking spaces. Of these, 324 are in Lot A that cost $1 per hour to park. 241 are in Lot B that cost $2 per hour to park. 75 are in Lot C that cost $3 per hour, and 360 are in Lot D, which costs $4 per hour. A parking space is selected at random. Let X represent the hourly parking fee for a randomly sampled space. Find the probability distribution of X. To find the probability distribution, we must list the possible values of X and find their probabilities. The possible values of X are 1, 2, 3, and 4. Next, we will find their probabilities. So the probability of 1 is equal to the number of spaces that cost $1 over the total number of spaces. Which is equal to 324 spaces that cost $1 over the total number of spaces was 1,000. So our probability here is 0.324. Similarly, we get the following for the probability of 2, 3, and 4. Thus, we see the probability of 2 is 0.241, the probability of 3 is 0.075, and the probability of 4 is 0.360. Now we're going to fill in this table to complete our probability distribution. So when X is 1, the probability of X is 0.324. When X is 2, the probability of X is 0.241. When it's 3, it's 0.075, and when it's 4, it's 0.360, and there is our probability distribution. Probability distributions can be represented with histograms to visualize the distribution. Example 6. Draw the probability histogram from example 5. So this is the probability distribution from example 5, so now you're going to draw the probability histogram. Here's the probability histogram. We just list the x's on the bottom, the probabilities on the y-axis, and then you just draw it like a normal histogram. Recall that the mean is a measure of center. The mean of a random variable provides a measure of the center of the probability distribution of a random variable. To find the mean of a discrete random variable, multiply each possible value by its probability and then add these products. So mu of x of a random variable is equal to the summation of each x times the probability of that x happening. Example 7. A computer monitor is composed of a very large number of points of light called pixels. It is not uncommon for a few of these pixels to be defective. Let x represent the number of defective pixels on a randomly chosen monitor. The probability distribution of x is as follows. Find the mean number of defective pixels. From our formula, mu of x was each x times the probability that happens. So we have 0 pixels times that probability, which is 0.2, plus 1 pixel times 0.5, plus 2 pixels times 0.2, plus 3 pixels times 0.1, which gives us 1.2. If we imagine each rectangle in a probability histogram to be a weight, the mean point is the spot where the histogram would balance. So if you were to take this histogram and you were to put your finger right where that arrow is, that's where the balance of the histogram is. There are many occasions on which people would want to predict how much they are likely to gain or lose if they make a certain decision or take a certain action. Often this is done by computing the mean of a random variable. In such situations, the mean is sometimes called the expected value, and it is denoted by this E of x. If the expected value is positive, we expect to gain. If the expected value is negative, then we expect to lose. Example 8. A mineral economist estimated that a particular venture has a probability of 0.4 of a $30 million loss, a probability of 0.5 of a $20 million profit, and a probability of a 0.1 of a $40 million profit. Let x represent the profit. Find the probability distribution of the profit and the expected value of the profit. Does this venture represent an expected gain or an expected loss? The probability distribution is as follows. If you remember, we had 3 possible outcomes: a $30 million loss, a $20 million gain, and a $40 million gain with those associated probabilities. Note that 30 is negative since it was a loss. The expected value of x is going to be negative 30 times 0.4 plus 20 times 0.5 plus 40 times 0.1, which is equal to 2.0. So again, remember, we're just calculating the mean. So this is an expected gain, since it's positive, of 2 million. The variance and standard deviation provide a measure of spread for the probability distribution of a random variable. The variance of a discrete random variable x is given by the following. It is the summation of x minus mu of x squared times the probability of x. Or equivalently, and this is easier to compute by hand, it is the summation of x squared times p of x minus mu of x squared. So if you're doing it by hand, that's the easier way to do it. The standard deviation of a discrete random variable x is the square root of the variance. So again here, standard deviation is still square root of variance. Example 9, we're back to that computer monitor example. It has the same probability distribution. This time we're going to find the standard deviation for the number of defective pixels. First we need to compute the variance, which was the summation of x squared times p of x minus mu of x squared, which is equal to 0 squared times 0.2, which is the probability that 0 happens, plus 1 squared times 0.05, the probability that 1 happens, plus 2 squared times the probability of 2, plus 3 squared times the probability of 3, minus the mean squared, which was 1.2 squared. This gives us 0 plus 0.5 plus 0.8 plus 0.9 minus 1.44, which gives us 2.2 minus 1.44, which gives us 0.76. So that is the variance, but we need standard deviation, which, as a reminder, the standard deviation is the square root of the variance, so standard deviation is equal to the square root of 0.76, which is equal to 0.872. So the standard deviation for the number of defective pixels is 0.872.